Hello, everyone. This is Sitaram. I'm a principal solution architect at Anuta Networks. In today's session, we will be going over a couple of these cross-domain automation use cases, and we will also look at some of the workflow features that we have brought in. So, so here are some of the cross-domain automation use cases that we'll be looking at today. Let's start with the first one, which is the multi-domain automation. Now, when you look at large enterprises have both a good mix of the legacy network as well as the SDN-based solutions. Now, with the increasing number of remote and mobile users, security and ensuring consistent policies across all these users and all the domains has become very important. Now, security and SD-WAN are converging and trending towards the SASE-based solutions. We're also seeing a lot of workloads getting migrated into public clouds like the AWS. Now, each of the domain controllers are doing a good job in their respective domains. The challenge comes in when we are trying to tie all these controllers together to solve customer use cases. Now, let's look at one such use case. Here is a use case where let's say there is a company that is deploying two types of branches or sites in their network. So the first one could be a Cisco Meraki based branch, and the second one could be a Cisco SD Access based branch. Now, from a network operator perspective, right, when you look at what he needs to do, so he has to work with multiple of these controllers and systems. A typical process could start with, let's say, opening a change request in a ITSM ticketing system like ServiceNow. And after that, he has to get into a IPAM like a netbox and reserve the IP addressing and VLANs. Now take that information and get to the site provisioning. And if it is a SD access based branch, he might have to log into the Cisco DNAC, do the branch provisioning, and Cisco vManage controller to provision the SD-WAN fabric. And if it is a Meraki based, he needs to log into the Cisco Meraki controller and do the provisioning. If workloads are deployed in public cloud, then again he needs to interact with AWS cloud and deploy the workloads. And if security needs to be enabled, he needs to get into Cisco umbrella and do the provisioning there. Now, the challenges, right? So he needs to work with multiple of these controllers. That is one challenge. And the second thing is, and some of these controllers might be very click ops heavy. So basically, he logs into the controller, and it's probably not a single screen where he can do all the operations, but he probably will have to navigate to multiple of these screens and a lot of clicks to provision something. And the third thing could be a manual exchange of information between all these systems. So, for example, he takes the IP addressing information from Netbox, use it to provision the site. Then let's say he also needs to map the virtual networks in DNAC to the service VPNs on the vManage. Again, when enabling the Cisco umbrella cloud security policy, he also needs to know the endpoints in AWS and as well as the user subnets or the subnets of interest in the site. So there is a lot of manual exchange between all these controllers, and all of this process could be very time consuming. It could be spanning across different teams as well, and it might also be error prone. Now, what Anuta offers here is a workflow automation. Now, that can be invoked from a OSS BSS portal or by logging into Atom UI as well. So let's actually get into the Atom UI. So let me bring up Atom UI, and then we'll look how we are doing the provisioning there. So let me bring up my UI here. All right. So this is the Atom UI, and we have what we have here is the workflow catalog. Now, all of these, so Atom Anuta provides a lot of out-of-box workflows. These workflows can be assigned tags. So let's say that you have some troubleshooting workflows or something to do with BGP, you can assign tags. And all of these tags could be grouped together to form tag groups. Now, these tags and tag groups help with organizing your workflows better. And you could also use these tags groups for search functionality. So here we have few examples. We have few tags groups here where we have for troubleshooting SASE remediation. Now let's click the SASE. So these are our some of the workflows that we have for the SASE-based grouping here. So since we are talking about the site provisioning, so let's get into the campus and branch provisioning. Now here is the process automation that we have for the site provisioning. Now, for a network operator, when he logs into the system, or this could again be from my OSS BSS portal, if he has to order a branch, what he has to do is he just has to click on the start and give in some information. So let's say that I'm actually provisioning a, let's say a SFO branch. What I need to do is just key in this information, submit this one, and the network operator would be presented with a UI form here. So where he keys in all the required information. And in the interest of time, what I'll do is I'll just, I have actually filled up a form here. I'll just quickly go over this one. So he will be presented with a single form where he keys in all this information. So he chooses which type of branch he wants. Is it a Meraki-based site or a SD access branch? Once he chooses Meraki, he gets some of these options. The Terraform server, where he can invoke the AWS scripts from, the WebEx controller, which is used to send the WebEx notifications, Meraki controller, Netbox, the branch name here, the ServiceNow system where he opens the ITSM ticket, the Cisco umbrella controller here, and few other details. So once he keys in all this information, again, it's a single form. And we also have this option to, he can choose if he wants to deploy AWS workload, enable cloud security. So he goes ahead and places a request here. Now, again, in the interest of time, what we have done here is we have a video that could be played. So this is a recorded demo. And let me go back here, start this one. Okay. So where we left off in Atom UI, so this is where we started this video. So the network operator has filled in this information, and then he would go ahead and submit the information. Now, once the information is submitted, the workflow moves ahead. So we are at the next block where there is a service request block where a service request would be opened. But what I've done here is I have logged into some of these systems. So the Netbox system to actually to see the state of these controllers. So this is the subnet that we have given in the input form. So this is currently unreserved. So this is available. And in the Meraki, we do not have the branch name here. So we are provisioning a Dallas branch. And likewise, this is our AWS account, and this is where we'll deploy our workload. So we currently have one VPC and one Linux server. Nothing from that, nothing apart from that. And here is the umbrella controller where the rules are disabled currently, or they're blocked currently. So this is the current state of the controllers. So as I was saying, the first step is to open a change request in ServiceNow. So let's navigate to the. So here is the task log. So we will grab the ID of the ServiceNow ticket. So we have a correlation between the workflow and the ServiceNow ticket so that it's easy to identify. So we take in this number and let's search for this number in the ServiceNow. So here is the change request that was created. And let's look at the information here. So it's a Meraki-based branch. The name is the Dallas branch. Cloud security is enabled. So this is the service request that was created.
Quick question.
Okay, and
you mentioned Meraki control. So you're talking about the Meraki dashboard, right? Or is there another some controller that? Okay.
No, sorry about that. Yeah, it's a Meraki dashboard. Yes. Um, right. So what we have requested for the approval of this particular change, and we'll also approve this. So we'll assume the role of a change management controller. So we'll go ahead and approve this particular change here. So the change is approved, and then we would see the workflow move to the next stage. So the workflow would take this route, which is the Meraki branch route. So the next stage is Netbox. So we will be doing IP reservation here. So let's navigate to Netbox here. So earlier, this subnet was active. So currently now we see that it is reserved, and we also have a description for the Meraki Dallas branch here. VLAN 101 is being used as a data VLAN for this site. So IP prefix is reserved here. So this is the second stage. So the first stage was the opening the change request. The second stage is reserving the IP address in Netbox. The third is provisioning the site by integrating with Meraki dashboard. So here is the Dallas branch, and the branch is provisioned. It's all green here, and we have one device at this particular branch. Let's also look at some of the details in the branch. So like the addressing and VLANs. So this is the VLAN 101, and this is the subnet that we fetch from Netbox. So this is configured in the branch. And let's also look at the VPN. So we establish a site-to-site VPN between the Meraki branch and the Cisco umbrella. So that's what you would see here. So, and we enable it for the VLAN 101, which is the data VLAN here. Okay, so once a branch is provisioned, the workflow moves to the next stage, which is the AWS workload deployment. So currently the workflow is here, and it's deploying the workloads. So we would create a host VPC and EC2 instance. So a host VPC has been created. And a host server is also created. So host VPC server VM, so that is created here. So this has a elastic IP assigned. So this is the IP address 381.197.34. What we'll be doing is before enabling the cloud security, we will try to ping this particular IP address from the branch. Going back to the workflow, we can see this particular IP address in the task log that we have. So let's navigate to that particular task log, grab the IP address. So this is the same IP address, 381.187.34. And what I'm doing here is from the MX85 device in this particular branch, be able to do a ping test with a source VLAN as 101. And the ping would fail because we have not yet enabled the cloud security policy. So earlier we have seen that the policies have been blocked. So we will have the workflow move to the next stage, which is the umbrella security provisioning. And then the rest of the blocks are pretty quick there. So here is the umbrella. So I did a refresh. And what we have done is we have enabled the first rule atom rule here. And we understand that the firewall policies could be very complex here. And again, but for the demonstration and understanding purpose, we have kept it simple here. So now that we have enabled or allowed the traffic on Cisco umbrella, let's go back to the Meraki branch. Let's again initiate the ping here. So the ping should be successful. So yes, you see that graph there. So that indicates that the ping is successful, and we have a connectivity between the branch and the AWS workload. Now, coming back to the workflow here, right? So what you have seen here is, just to summarize, we have opened a ServiceNow ticket. We have reserved IP address in Netbox. We have integrated with the Cisco Meraki dashboard to provision the site. We have deployed workloads in AWS. We have enabled the security policy in Umbrella. And that completes the provisioning. And the next set of blocks are to update the ServiceNow ticket here, close it, update the notes. This is more like wrapping up your change here. So these are all the notes. As the provisioning goes through different stages, right? So we go ahead and post messages in the ServiceNow ticket. So those are the messages that you are seeing there. And we can also send messages to the WebEx rooms here. So we have a NFT32 room here. And as you can see here, as we went through the Netbox provisioning at each and every stage, we have posted few messages. Likewise, for Meraki, the Terraform scripts being executed. So for the AWS deployment, you see that Umbrella pre-checks, enabling the firewall, all of these, and finally saying that the Dallas branch site has been provisioned.
If you're at the final stage and the workflow step fails, so do you go back, roll back the previous stages, or what do you do actually?
So that's a very good question. What we do is we have a very robust error handling mechanism. At any stage, if the workflow fails, now there could be multiple ways of looking at this one. So let's say that it's a simple retry would actually fix it, right? So we have that provision to go ahead and do a auto retry to again provision that particular block. And in some cases, that wouldn't work. And there is a deeper problem where a user intervention needs to be done. So we actually present a form for the user to come and see what has happened and then take an action appropriately. So that could be either he fixes something and then he lets the workflow move ahead, or there could be scenarios where a valid backout is probably to do a rollback. So that also can be done. So we have all these options that could be carried out through Atom workflows.
Okay.
I have a question as well, kind of on that vein, which is, if a step perhaps doesn't fail, but it gets to a point where, a user has to make a decision and they've come to the point where they're like, oh, actually, I don't want to do any of this at all. How do you basically stop that workflow and, deprovision all of the resources that you've set aside and all of your other controllers that you're managing from this system?
Correct.
Is that something you have to manually go and build into your workflow, undo steps for every do step, or is it automatically derived, similar to how Cisco NSO has fast map for network devices where it will figure out what to undo? What's the kind of developer, or I guess it's low code, so maybe not developer, but the end user's experience writing a workflow that can be undone or using a workflow that can be undone?
So for some of the stateful scenarios, we do have a scenario where we can generate the rollback and the undo scenarios or commands or instructions. But for some of the scenarios where it's more like a stateless operations, like operational commands, like a image rollback, in those scenarios, we do need to have some guidance from the operational team as to what their rollback stage will be and when the rollback itself need to be attempted. So again, I think based on the scenario, Atom has necessary building blocks to be able to auto-generate, and also in cases where it requires guidance, operations teams can fill in what needs to be done.
Right. Did that address your question?
Yeah, thank you. I definitely have another question, kind of on a different note. I'll have a lot of questions, sorry. But I see that this demo does a lot of work with systems that have APIs. And I know you mentioned your use of Yang earlier. I would like to hear more perhaps about both how Yang is used as an end user of Atom to define things, as well as how you talk to devices that might not have an API or CLI devices, things like that.
Right. So we do have inbuilt adapters for the CLI devices, the traditional CLI devices, and the netconf devices as well. And again, those adapters are also something that you can build easily using the adapter builder library that we have. So all we need to do is just consume the Yang that the vendor publishes, and as it is, those become our device adapters. Now, what we also give an option to the end user, right, is to create their own service adapters. So that's where you pitch in your own custom Yang. And once the custom Yang is built in, you probably just have to do the mapping between what are the leaves that you would want to map. So there are again, low code, auto-generated boilerplate codes available for you, where you need to just tell the mapping thing that this is the device leaf and this corresponds to this particular service leaf, or it's probably a concatenation and stuff. There's some sort of fine tuning that you would like to do to it. So all of that comes along with the SDK, which Atom comes, and I think that takes care of most of the CLI devices and stuff. Apart from this, if the end vendors also don't publish their own Swagger documents or the open API spec, we have generic API adapters, which also encompasses Redfish APIs, the generic REST APIs, and other SOAP protocols, etc. as well. So yeah, it's pretty well covered in that aspect.
Okay, thank you. And so when you're mapping, specifically in the Yang discussion, when you're mapping between Yang leaves, right, or Yang to CLI concepts and things of that sort, what are you doing that mapping in? What languages do you have available to you? Is it just a low code like UI where you're kind of linking this stuff? Can you do in Python or Rust or Go, or what's the kind of developer environment for that?
Right. So the mapping is traditionally done using Python. But we do have a sort of UI where you could just do that mapping straight away, and that's where we have these easy flow templates as well. Yeah.
Thank you.
All great questions. Thank you. All right. So coming back to the automation, right? So
I have a question.
Yeah, sure. Go ahead, please.
Yeah, do you create device and service models? So let's say if I create a service model for layer 3 VPN, I have 3 different vendors, Nokia, Huawei, Cisco, etc. And towards the OSS, you just expose one set of API, so you abstract them. So there is really, you make the job of OSS very easy. So really, do you create those service models and make it easy for OSS to consume them, or you expose 3 different sets of models?
No, so the service model, like you said, it's an abstraction layer for us. So we do not want the end users to sit and worry about how the mapping is supposed to work, or the payloads that are going to come from any northbound system. So that abstraction layer basically takes care of the logic. So it's not going to be 3 systems for sure. And another thing that I would like to add, right? We also consume TMF payload. So the TMF probably becomes your higher level abstraction layer, where you place in your service order request that internally again gets translated into service request, which goes into the customer facing services. So that layer of transition, or the hierarchical deployment, is also something that we are proud of and we support. So to the end users, to the northbounds, to the ITSMs, it's still going to be just the one layer, which is the abstraction layer, and not the individual model.
Kind of on that topic of abstractions of these models, are you using public models for things that already exist, things like L3 SM and L3 NM from IETF for network and service models, respectively?
That's true. So we can consume any of the IETF models. Like I said, we can consume the TMF standards as well. And we also encourage the end customers to, bring your own models. So all of these flavors would be supported.
So coming back to the use case here, so we have successfully deployed a branch here. And so this is the final step, which is to send an email notification. So now that we have seen a site deployment, right? So let's look at a day in operation. Like let's say that you have an SD access branch deployed, and the branch is using the SD WAN from managed by the vManage controller, right? So let's say we get into a situation where a policy needs to be updated on a vManage. So probably there is a network outage, and we have to actually go ahead and update the policy. So this could be seen as a day end kind of a use case here. So let me move to the next video here. So this is to do with how we actually update the policy on vManage Fabric, SD-WAN Fabric here. So let me quickly spend a minute on this one. So as I was saying earlier, so let's say there is an outage, and the network operator team is actually alerted about this outage, and they need to take a remediation action. So what they do is they open a incident ticket in ServiceNow, and that triggers a workflow in Atom. And Atom goes integrates with vManage controller and pushes a policy update and remediates that particular issue here. So this is the exact use case that we will be looking at. So let's go ahead with this demo. So again, to start off with, so this is the vManage controller, and we have a application route policy here. Now, currently, the preferred color over here, or that translates to transport, is blue. Now, let's assume that there is an outage, and the network team is informed about that. So the team goes ahead and opens a ServiceNow incident ticket. So this is how they do it. So they given some description saying that they want to update the preferred color to MPLS. So that's the remediation here. So they would fill in some of these details. Once the ticket is submitted, so this invokes a workflow in Atom, and Atom gets the instructions from the ticket here. And so this is where this is the policy update workflow that we are seeing here. So this is triggered by ServiceNow here. So again, we are performing some pre-checks here. Then again, opening a change request. Again, any implementation that we do, we open a change request in ServiceNow. So we are at this particular stage, and so let's also look at a quick thing. So we have Atom webhooks that can be invoked. So ServiceNow is invoking a Atom webhook. So that's what you see here, and this is actually invoking the Atom workflow here. So that's how the workflow gets triggered. And let's again grab the workflow ID from the task log and then search for it in the ServiceNow system. So this is the workflow ID. Let's get to ServiceNow, search for it. So this is the ticket, and it has some of these details. And as with the previous use case, we go ahead with the approval process. So once the approval, we get the approval, so the workflow moves to the next stage. So the change record has moved to implement, and the workflow has moved ahead. And the rest of these steps are quite fast. So what you're seeing there is Atom invoking the vManage controller APIs. And then after that, performing the post checks, and then finally closing the change request and sending a Slack and email notification. So this is an example of how we can do a day-end operations using workflow, Atom workflows. So here are all the task logs here. So we finished the process here. And let's look at the vManage controller. We should see the preferred color to be updated. So let's wait for it to refresh. So as you can see, the preferred color has changed from blue to MPLS. So that's our intended action here. So like with the previous use case, so we go ahead and update the ServiceNow ticket at regular intervals at each and every milestone. And finally, we also send an email notification. So, right, just to summarize, right, so in these two use cases that we have demonstrated, so the first use case was talking to multiple controllers where we are deploying a site. And the next use case is a day-end kind of a use case where we are, after the deployment, we have a scenario that needs to be taken care, and we have done that using the Atom workflows. Let me go back to the Atom UI here. So we have seen the deployments here. So let's talk about the advanced workflow features that we have. So we have workflow heat maps that can be enabled on workflow definition. So I have this campus branch provisioning workflow here. And what I do here is I enable the heat map here. And we support two types of heat maps. One is a duration based. So basically, this is rendered based on the average time each step in the process spends, right? And this is across all the instances the workflow has triggered. So let's say that you have 500 or 1,000 of these branches deployed, and you turn on the heat maps, you would actually see where your workflow has spent the maximum amount of time relative to the other steps in the process. So the darker the shade or the color means the workflow has spent more time over there. So this is one example, and we also have a count base. So this is again based on the number of times each step is invoked across all the workflow instances. So this actually gives you the path or the most the most taken path of the workflow. So in this case, right, so we had both Meraki provisioning and SD access branch provisioning. And the top path that you see where you have a lot of colors here, so this is the Meraki-based provisioning. So looking at the workflow, you can say that there were a lot more Meraki sites provisioned when compared to the SD access branches here. So how do these heat maps, how are these helpful, right? So from a network operator point of view, he can actually look at these heat maps and find out where the bottlenecks are. So let's say that when I look at duration based, right? Now in this heat map, we are seeing quite a few, the color, right, is maximum at the initial stage, which is the user input here. So what it means is the operator could be just triggering the workflow and not giving any inputs here, right? So this could be inferred from this particular heat map here. And the next thing is in the provisioning, Meraki is taking longer time with respect to the AWS deployment or any of the network or the umbrella cloud security provisioning here. So when you look at this path, right? So a lot of time is spent here. Meraki dashboard is taking provisioning is taking longer than the others here. Okay, so in this way, the network operators can see these heat maps and optimize the processes. And from a developer perspective, when he looks at these heat maps, it could mean that maybe a process, a workflow needs a code optimization, or probably the application itself needs additional resources to be assigned. So each of these groups could use these heat maps in a different ways here. Okay. Now, let's also look at the heat map of the policy update. So this is the heat map of the policy update. A lot of time is spent in the change request process here. Now let's look at the workflow dashboards here. So now this is the workflow summary or the dashboards here when a network operator comes in. So this could be the landing page for him. Now he has some information that could be useful for him, like how many of my workflows are in error or in progress or have been completed. And coming to the user action, so maybe he has to give an approval for any of the changes, right? So could actually see how many of are assigned to him versus to the entire team, how they are doing with respect to approving some of these changes or reviewing some of these changes. A few other stats that we have here is the fastest and the slowest workflows here, and some of the trends here. So on a weekly or a daily basis, you can see how many workflows are getting executed, how many are going to completion, how many are in error states. So he can also get these information from the trends here. Now, we also have these planned activities. This gives him an idea of how many changes are scheduled in the coming days to weeks here. So he could have a quick view here, or he could actually navigate to the change calendar itself or the planner itself. So he could see what are all the changes that have been scheduled. So this, you can view this as a probably a change management calendar here. So you know what is actually exactly happening here. What are all the things that are scheduled in your network? So if he needs to execute something, right? So all he has to do is he has to drag and drop this particular workflow and fill in some of these parameters. If some of these are repetitive, let's say that you have some workflows, purely monitoring based workflows. So you could actually drag and drop those workflows, schedule them probably on a weekly level, daily basis, and things like that. So the planner can come in very handy for such kind of use cases. Okay, and one other thing on, yeah, any questions?
I see your use of NSO there, and I just wanted to clarify: is that the version of NSO but from Cisco, or is that your term NSO of network service orchestration? Because I've seen that term a little bit overloaded in some of your documentation. I wasn't quite sure what you meant on that calendar by NSO.
Calendar, okay. I believe this is, one second, let me bring it up. So we have a workflow here where we are integrating with Cisco NSO. Yeah, so this one, right, L3VPN NSO. So we have tight integration with Cisco NSO, where we can provision L3 VPNs by integrating with NSO. So NSO does all the provisioning and everything, and it gives back the status to Atom here.
Very cool. Thank you.
Yeah.
Oh, one more question. I assume that you're using the just the netconf style interface, and you're importing NSO, the Yang models that have been written for NSO into your system, and using that to build these workflows versus having to do some other integration with a REST-conf or Yang batch style API.
Atmash, can you take this question? To your answer, yes, we are integrating using the netconf APIs. Atmash, can you add more?
That's true, Chris. So we basically mounting the Yang paths, like you said, and the transactions take place in the same pattern. And just a little bit more context, right? So again, NSO also is like an abstraction layer, and why do we have to sit on top of it, right? Coming back to our whole story that we are trying to display today, it's cross domain, right? So if we begin with the underlay, probably the NSO L3 VPNs can be used to provision the underlay. On top of which, you start stacking your SD-WAN layers, the SDN layers, and stuff. So again, NSO, even though it acts as an abstraction layer, it still needs an orchestrator on top of it to basically act with other systems. So yeah.
Yep.
Continue.
Makes sense. Thank you.
Thank you, Atmash. So a quick last point on the summary here. So you can use the filters, and you can also bring up the heat maps on this particular summary views here. So that is also possible. Okay. So with that, let me, if any questions, we can take it, or we can go back to the slide deck and go over some of the multi-domain use cases. All right, so let me go back here and bring this up. Let me swap this. All right. So we have gone through this use case. We have seen a demo of this use case, and we have also gone through this particular slide. So let's talk about this use case here. So one of the prominent use cases in enterprise is, how do I leverage the public cloud for my WAN? Now, in this particular use case, what we are doing here is we are integrating with Cisco vManage and extending the SD-WAN fabric into the AWS cloud. So we are deploying cloud gateways here. Again, this is going through the vManage controller. Atom integrates with AWS and does the host VPC and workload deployments. And Atom also integrates with Cisco DNA controller to provision the branch and establish the connectivity all the way from the branch to the workloads in the AWS. In addition to that, Atom also integrates with Thousand Eyes. The Thousand Eyes agents in the branch, they monitor the connectivity from the branch to the AWS cloud here. So in case of any performance degradation, an alert is generated in Thousand Eyes, and this alert can be consumed by Atom to raise a ServiceNow incident ticket. Now, once the ticket or the issue is remediated, Atom also can go ahead and close the issue there. So we are integrating with a lot of controllers in this particular use case. The next use case is more on a closed loop automation kind of a use case. Here, Atom is configuring the underlying network. So it does all the provisioning, the BGP configurations, and the VPNs and everything. And any kind of network outage, right? So the Oracle Unified Assurance Platform get notified. And this platform invokes a workflow in Atom to do the troubleshooting as well as the remediation activity. Once the workflow is figured, Atom checks with Oracle Fusion Cloud and sees if it is part of a planned activity. If it is not part of a planned activity, it goes ahead and opens a service request in the Fusion Cloud, and then goes ahead and does the remediation and does the finish of the change by closing the service request here. So this is a assurance or a closed loop automation kind of a use case. Now the last one is a cross-domain automation use case for a service provider. Atom helped expedite the cell-site deployment for this particular customer. Now, Atom is the cross-domain automation platform here, where we integrate with a lot of the domain controllers here. So we integrate with Cisco NSO, and NSO takes care of the provisioning of the routers here. Atom takes care of the server provisioning. It also integrates with Infoblox for IP addressing needs, and also with GitLab for provisioning the underlying or executing some of these operations like the vCenter installation, Kubernetes, and things like that. Atom also integrates with inventory system, the Blue Planet inventory system, and fetches the information that is required to provision the cell site routers here. Atom also has a custom reporting framework where you can build reports. So for the customer, we have built live deployment reports and exec dashboards that could be viewed to see the status of the deployment at these cell site routers. Moving on, so as I was saying earlier, Atom provides a lot of out-of-box workflows. We can integrate with domain controllers. We can also talk to devices directly. So we do support both kind of use cases with controllers and without controllers. With this, we can take further questions, or I'll hand it over to Kiran.
I have a quick question. So a lot of the demos and stuff that you showed, it's very heavy Cisco focused, right? I know you mentioned 60 plus vendors that it supports. Can something similar be achieved or without any restrictions? Like, I don't know, let's say with Aruba or Juniper Mist or other vendors that are cloud-based vendors, for campus networking and that kind of stuff. Like, I can create some kind of workflows using their APIs also.
Yes, that is right. We do not have any restrictions on the vendors. So we are vendor agnostic, and we can integrate with any vendor that has proper interfaces, yes.
Okay, so same exact thing, like, for example, like I currently have like a, script that will go, it's a Python script that will go and utilizing their APIs, it will provision their site and based on the variables like network, VLANs and everything that I define, it will push it out there. So with this, I can basically point it to their APIs. It will download their APIs from the web or or wherever, and then it will automatically create packages, as I understand, and I can just easily then utilize those packages to kind of put the pieces together and provision a site or multiple sites.
That's right. So we have support for Swagger APIs. You can point Atom to that particular website, download the APIs, create packages. And we also have a lot of out-of-box libraries. So you could make use of these libraries and packages and come up with a workflow. That's right.
All right, cool. Thank you.
Yeah.
Another question here. What does the northbound API look like on Atom? So if I need to integrate, yet another controller into Atom, so I need to drive Atom from something else, which is probably a common use case for some folks, especially when you mention SPSS integration. What kind of API does that look like?
We support REST APIs, northbound.
Cool. And I'll ask IPv6 question. Does this work in an IPv6 only environment? Because I know for us, our management network's entirely IPv6 only, so we would need that if we were to use something.
Kiran, do you want to take this?
So with the, am I on? Yes.
Go ahead, stand by the X.
All right. So with the IPv6, we can configure the devices with IPv6 addresses, but the manageability of the Atom as well as manageability of the devices is still through IPv4. So it's a partial support, and we will continue to enhance that.
Okay, thank you. Is that roadmapped or is that maybe in the future sometime?
I think maybe in the future.
And just to answer to your previous question, right, Chris, on the northbound part of it, I think REST is definitely one way to go, but we also have our own event listeners. So the end products, whichever are on the northbound, they can probably publish to these, whether it could be a Kafka scheme or just a webhook endpoint, right, on our end, and we'll have these active listeners, which could in turn again trigger workflows or any other automations for that matter within that. That's just a continuation. And netconf notifications as well. So NSO and all of this stuff, right? We just receive those event streams in the form of netconf notifications and we can still consume it. There are various ways of interacting with it.